'Cause I wasn't paying attention. Oh my god. Oh, yes, it's recording now.
Yeah, now I see it. All right. Good morning, everyone. So I want to make sure that you guys are able to access the agenda. So always start off by one, giving us that date of birth in the chat before we continue with anything, but also that you're opening up your agenda for the week. So under Google Classroom, if you go to classwork, click on the week 5 agenda, which is right underneath your week 5.
Hey
So when you
Alexis, can you put your birthday in the chat room, please? And Lauda, can you put your birthday in the chat room? So Alexis and Lauda, those of you guys coming in, can you please let me have that? Because I just started getting, man, that guy is from like the Czech Republic, because
yeah,
that's like Russian stuff right there.
wants to learn math in the USA,
There you go.
in Little Coachella.
Thank you, Lauda. I see that. Alexis, I'm still waiting on you, or else I'm
It's
gonna
for
kick you out.
it's our YouTube fans. No, I'm just
I
kidding.
know.
I'm just kidding. All right. So make sure you are clicking on that week 5 agenda. It'll give you a little breakdown of what's going on today. We have decided to change things up today. So let me start off with these announcements here. So based on the feedback that we have receiving from you guys on the homework assignments from Monday and Tuesday, we're deciding that we are changing it up today. And instead of continuing to a new set of notes, we decided let's focus on reviewing what we've done Monday and Tuesday. And by the end of today, you should feel a lot more comfortable with working with linear and exponential tables. So it shouldn't be too long of a class. As you can see, we're only writing down notes, and it's only 1 page of notes. And then from there, we're going to hopefully give you time to work on Mondays and Tuesdays assignments, but we will review Mondays and Tuesdays assignments, especially Tuesdays, which is what we've been getting questions on. And then the other announcement is that we will be having our second quiz coming up on Friday, April 23rd, which is next week. All right, so again, for today, we only have that week 5 notebook. If you want, you can go ahead and get that opened up already. So click on week 5 notebook. Make sure you're logging in or that you're using the exact same name as you have this whole week. We're going to be on page 3, which looks like this. So we're taking a review day to make sure you're understanding how to work with all of these tables. We're going to give you some more steps here. Let me take a look on ClassKick, make sure you guys are joining us there. So this is a new page we added onto the notebook. So I know some of you guys like to get ahead and finish your notebook before the end of the week. So make sure you go back and complete this page. This was just added in there yesterday. Yes, I saw that. And it's correct, Emelisa, good job. All right, more of you are popping up here. So while you guys, again, are clicking on your week 5 notebook, page 3, I am going to start you guys off with a this or that question. I would wait to make sure, I think we saw, and yours seems perfect. Oh, there's a couple pieces that you want to put in the correct spot. Looks like, yeah, I would wait, because looking at the your turn for Friday, there's some changes I'm going to want you to make to it. So wait till tomorrow. Sorry, someone was asking if they were finished with their notebook, if they should just turn it in. And it's good that it is finished, but I would wait until Friday or the last day we do notes together to make sure there aren't any changes you want to make to it. And changes happen all the time. We might make a change to the notebook, so you probably shouldn't turn it in yet. All right, since a lot of you are joining us on ClassKick, I'm going to go ahead and get you guys started with today's little warm-up activity, okay? Usually we like to give you those this or that questions, like the Kit Kat bars, waffles or pancakes, Superman or Batman, but we're going to get a little mathy today with your this or that question, because it is a math class. And to get you thinking about these different types of functions we're working with. So this is your this or that question for today. You have two options for a savings account. Remember, a savings account is just where you put in money and you watch it grow in a bank account. So option A for your savings account is that you start a savings account with $10. Every month, the amount of money in the account increases by $2. So that's the first option for a savings account. Would you want to have that savings account? Option B, you start a savings account with $10. Let me get my pointer. You start an account with $10, and every month, the amount of money in the account is doubled. So take a good look at these two options, study them, analyze them, think about what option for a savings account would you rather have, A or B? And once you've come up with your answer, just type it in the chat there. You can type in A if you would want a savings account like A, or type in B if you would want a savings account like B. Somebody
While
saying,
you guys are thinking of that, is there anyone that's having issues getting into their agenda by chance? Because we were having people have issues in first period. And if you're having issues, say me in chat, and then tell me if you're on a computer or an iPad. Because that does make a difference. And
yeah.
I think I know why some of you guys might be having issues.
All right, now for those of you that are giving me your answers in the chat, think of a reason why. Why would you go with A? Why would you go with B? Some of you are saying no brainer. I'm going to go with this one. And someone said this easily. All right, so think about why that is. Is there anyone, are they able to unmute themselves or?
Yeah.
Okay, is there anyone that wants to share with the class why you chose that? I'm getting a lot of Bs, by the way. Or in the chat, and I can read it out loud. Okay. All right, so just to let you guys know, we'll go ahead and get started with this. A lot of you are telling me B. And thank you guys for those of you that are giving me reasons why. I'll go ahead and read yours off since I know we're a little shy in unmuting ourselves. But I have one that said B because it's more easy to double the number. B because it is growing a lot. B because that's a lot of money. Yeah. Okay, good. So it's up to you again how you want your money to grow, but there is a better option here. And that definitely, yes, exactly. Good job, Juan. That it's definitely going to be B. B is the better option. But for some of us that were not able to see why is B the better option when it tells me that A is increasing, so that means it's growing. Why is it a better option? We're going to take a good look at these two options with some pictures, and we're going to connect it to what it is that we've been doing Monday and Tuesday. So some of you that were like, easy, I'm going with B, think about how it relates to Monday and Tuesday, what we've been talking about. But that should become more obvious right now as I show you some images. Okay, let's take a good look at option A, and I'm going to break it down for you. So option A, we can take a look at this in a little table, break down what's happening here. To start with, that first sentence, they're telling us you're starting a savings account with $10. So when I'm looking at my starting point, I'm going to have $10. So there's my $10. After a month has passed, remember it says the amount of money, or every month, the amount of money increases by 2. So that means on month 1, I'm going to start with $10, the ones I had in the beginning, but in that month, it's going to increase by 2. I'm going to get $2. So now in that savings account, you have 12. Month 2, you have those $12, and now you're getting 2 more again. So that's 14. The third month, we have those $14, but it increases, it goes up by $2 again. So now we have 16. So take a good look at this, the values of what is going on with your savings account, 10, 12, 14, 16. We notice, hey, my money's growing. That's a good thing. Otherwise, what's the point of a savings account? So what makes B better? Well, let's actually take a look at option B. It says we start off our account with $10, so I'm still starting with $10. That's the same. But what happens after that month passes? Well, every month your amount is going to double. So if we have $10 to start with, double it means I get another 10. So now I have $20. The next month we have those $20 and then we double that. So 20 doubled would be 40. On the third month, we have the $40 and that $40 is doubled. So now you have $80. So obviously by looking at it this way, by breaking it down, we see, oh, yeah, A is still making your money grow. That's good. But B is making your money grow even faster. So that is already showing us how these two savings accounts are different and how they're showing us different functions, which is everything we've been talking about these past 2 days. So let's go back at option A and look at it even further, really looking for a function. So very important, this account is starting with $10. So remember, we've been using this blue color for our initial value, our y-intercept. It's the starting point. So look, I've even color coded this for you guys. It's blue to show you this is the beginning. This is the starting point. Okay, so that is an initial value. So when you look at these tables, we're going to focus on the amounts now, just the amounts I have written down here, 10, 12, 14, and 16. We can see that there's a pattern in all of these numbers. Yes, Jimena, good job. Okay, when I look at 10 to 12, it's increasing, it's going up by how much? By 2. So we say it's adding 2 plus 2. 12 to 14 is also adding 2. And 14 to 16 is adding 2. So we have a pattern just by looking at how it's growing. How much are we adding each time? In this case, we're adding 2 each time. If we have an addition pattern, it's a rate, and we say, well, we'll talk about the rate in a bit, but that is a linear function. So option A, savings account A, is showing you a linear function. And that's what we've been talking about for these past 2 days. So now let's take a look at, well, if option A is linear, what is option B? Well, we still have our starting value, our initial value of $10. We're still starting the account with 10. When we look at just the numbers, just the values here, we have 10, 20, 40, and 80. What pattern do we notice between these numbers? How do I go from 10, yes, perfect, to get us to 20? Well, I can add 10. We can try that. Add 10, that gives me 20. 10 plus 10 is 20, so it seems like it's adding. But when we were talking about a pattern, it's consistent. It's the same at every stage. So 10 plus 10 is 30. It's not 40. So it's not adding. We are multiplying. And in this case, we're multiplying by 2. Good job, Jimena. So 10 times 2 is 20. Does that also work for the next stages? 20 times 2, yes, that's 40. 40 times 2 is 80. So we have an initial value, a starting point of $10, but our pattern here shows that we're multiplying by 2 each time. What type of function is that? That is the exponential function. So when we're talking about watching something grow, especially like money, we're going to want to go with an exponential function. Imagine if you're getting ready to get a job and they're saying, we're going to pay you an exponential salary. Well, you want to know if it's increasing or decreasing actually, but I mean.
Well, yeah. I would very much appreciate an exponential pay scale.
Yeah,
That
we'd
would
be
be nice.
Billionaires by
Woo-hoo!
early on in life. So exponential functions grow, and they grow fast because you're multiplying. So that's what we were talking about on our first day. Adding an addition pattern is a linear function. A multiplication pattern is an exponential function. And all you have to do to find the pattern is either add, subtract, multiply, or divide to get from one value to the next. So what we're going to do is move on to our notes for today, but it's still continuing with review. So this was an example of real life money, savings account, but how do we try to complete homework assignment number 13 when I just have tables? It's the same situation, but you're just seeing the numbers. So after today, you should be able to say that you can distinguish between linear and exponential functions. This is our learning objective for today. And we broke it down into three parts. One, can you see a table and tell if it's linear or exponential? Can you do that? That's basically the first part of the objective. The second part of the objective is, once you know it's linear or exponential, can you find the rate? And then, can you find the initial value? So there's 3 pieces to this objective, and we want to make sure that you're able to understand or accomplish this, these 3 pieces here. So we're going to move on to your notes, and we're going to go ahead and work through a couple of examples that are very similar to homework number 13, same format, but it should meet all of those 3 objectives. So we're going to start off by giving you steps. So when you see a table like this, how do we distinguish? How do we tell if it's linear or exponential? Well, your first step is going to be to find the pattern in the Y values. Just like we were looking at every month, how it increased, that's what you're doing, but on the Y side here, your Y values. So when you're finding that pattern, you want to keep 2 things in mind. Why are we finding the pattern? What does it tell us? We'll think about how our money grew. They were growing differently. The linear pattern is going to be addition or subtraction. Not all of these tables are going to grow. Sometimes we do have those tables that are getting smaller, and we're going to talk about those too. So your patterns can be, you can have an addition or a subtraction pattern. If you have an addition or subtraction pattern, we say that is a linear function. You can have a multiplication or a division pattern. And if you have a multiplication or a division pattern, we say that is an exponential function. So that first step of finding your pattern tells you if it's linear or exponential. So what do we get when we find out it's linear or exponential? What's so important about doing that? Well, the pattern not only tells you if it's linear or exponential, but it also tells you what kind of rate you have. How is your function growing or how is it getting smaller? So as soon as you decide this is a linear function because it has an addition or subtraction pattern, that pattern is called your constant rate of change. So an addition and subtraction pattern is linear and it's your constant rate of change. It's your slope. But if you've had a multiplication division pattern, then actually that is called the constant multiplier. So very different rates. You can't say a linear pattern, an adding pattern. We can't say that's a multiplier. No, that's not going to work. You only pick one of the two options. All right, so that is your first step. And that first step gives you basically all of the information we need, if it's linear or exponential, and do you have a constant rate of change or a constant multiplier. Remember, the linear pattern is called a constant rate of change. The exponential pattern is called a constant multiplier. So now that we have that, your second step is to find the initial value, the beginning. So think back to your savings account. It said we started with $10. The very beginning was 10, and then month one was where we went up to either $12 or 20. But our very beginning in this tables is blank. It's not there. So you have to take the extra step to find the beginning, but you just use your pattern for that. So the initial value is the start or the beginning where X is equal to 0. So we need this 0 up here. Okay, so that is how we would take, that is the steps we would take to be able to accomplish those three objectives. Can you tell if a table is linear or exponential? Can you find the rate? And can you find the initial value? Those are the three pieces of your objective. So we're gonna go over to your class kick notes. We're gonna go ahead and carry those pieces over. So to complete your steps here, all you have to do is put in your rates. On the linear pattern, we should call that a constant rate of change. So carry that constant rate of change, put it right under the linear pattern, get that constant multiplier and put it right under your exponential pattern. And then once we have our rates, we want to be able to find the initial value, which is the beginning, the starting point, where X is 0. Give you guys a couple seconds to complete that. All right. So some of you are noticing that there's a lot more pieces down here. We're going to be using these to complete your notes here. I know it can be difficult for some of you to write the pattern with your fingers. So I simplified it a little bit more for you guys, just so you also have notes to help you with your homework, to help you with any future quizzes, because remember, you are allowed to use your notes or notebooks when you're taking a quiz to reference back to. All right. So we're going to go ahead and work through an example here. So we have our steps and we see a table here. Let's use those steps to determine if this is linear or exponential, to find the rate of change or the constant multiplier and the initial value. So the first step says find the pattern in your y value. So here's my y. Let me take a look at this. We have 10, 20, 40, and 80. Okay. If you want to get a little idea or try to be on the right track of finding linear or exponential, so you don't waste your time saying, am I adding, am I subtracting, am I multiplying or dividing? You can take a look at what these numbers are doing. So from 10 to 20 to 40 and 80, my numbers are growing. So when we see that these numbers are growing or getting bigger, we know this is an increasing function. So increasing means we're getting bigger in our y values. So it's increasing, which tells me, okay, increasing, I have to make the number bigger, which probably means I'm looking at addition or I'm looking at multiplication. So you want to ask yourself, what can I do to 10 to get me the number 20? And that has to be the same to get me from 20 to the number 40, the next number, and from 40 to 80. It's probably not going to come right away off the bat. Like some of you guys are going to have to do trial and error. So if you want to start by adding, yeah, you can do that. There's nothing wrong with that. So I could add, well, 10, yes, Jade, thank you. 10 plus 10, that's 20. But is 20 plus 10 40? No. See, this is not consistent. When it's not consistent, that's not a pattern. So this is not the pattern. We have to try something else. So here, we can try multiplying. And I'm going to try multiplying by 2. So 10 times 2 is 20. 20 times 2 is 40. That's working out. And 40 times 2 is 80. So my pattern is consistent. It is the exact same number that I'm multiplying by each time. So now that you found your pattern for the y values, all you have to do is decide, is this a linear function or is it an exponential function? Well, multiplication pattern, here it is. That is an exponential. Yes, good job, Jimena. Exponential. So we circle exponential. So remember, we're on the exponential side. If I have an exponential pattern, then I have a constant multiplier. So for some of you that were trying to complete those homework assignments, homework assignment number 13, some of you were writing that as a rate of change. Nope. A multiplication pattern is not a rate of change. See this word multiplier? It is multiplication. That's an exponential pattern. So what is our constant multiplier? That is just your pattern. It was multiplying by 2. So you can either write 2, you could write times 2, you could write the dot 2. That is fine, but just writing the number 2 is also correct. So take a look at that. This pattern, this first step gave you these 2 answers. And all we have to do is move on to the second step. The final step is find the initial value. And that is the start, the beginning, where x is equal to 0. Well, my table has x as 1 here. I don't have a 0, but obviously 0 comes before 1. So 0 is before 1 there. Exactly. Good. So it seemed like when we introduced the notion of going backwards for the initial value seemed to confuse students. So we are going to show you a different way of thinking about your initial value. Is if we have a number here, we know our pattern is consistent. We know that this number here would have to be multiplied by 2 to give me 10. So you can ask yourself, what number here has to be multiplied by 2 to give me 10? And that would be, thank you, Jimena, 5. You could still think of the backwards notion if that helps you. You could say, well, I know my pattern is to multiply by 2 each time. Then if I'm going backwards, I could just divide by 2. Notice we get the exact same answer. 10 divided by 2 is 5 because we're going backwards. But if you're used to just thinking of your patterns as going forwards here, you could just think a number times 2 is 10, and that is 5. So that is our initial value. It's at 0, 5. All right, so I want you guys to go back to your your Classkick notes and bring those pieces over. So to complete these notes here, I don't want you to struggle with writing the pattern. So just look for your pattern here. We said it was multiply by 2. You can see a pattern of multiply by 2 there. So all you have to do is drag it right next to your table. Since we're multiplying by 2, we know that is going to be an exponential function. So all you have to do is just carry a piece here that circles exponential and put it over like that. We're on the exponential side, which means we have a constant multiplier. So I don't want to see the answer here for the pattern. I want you to just remember, X that out. We don't have a rate of change. I have a constant multiplier. What is that constant multiplier? Our pattern multiplied by 2. So I should look for a 2 here. There it is. And there's my constant multiplier 2. Yeah. Notice, let me show you here. Notice how it has constant in both of these. Because when we're talking about constant, sorry, let me repeat that question. It was, so even if it's constant, is it exponential? Yeah, the word constant means that is repeating over and over again. So constant multiplier means we're repeating multiplication over and over again. So the word constant will be coming up on both, because a constant rate of change means, is it changing by the same number over and over again? Yes, but a rate of change means we're adding or subtracting. So if you see constant, it's still, it could be exponential or linear. You could even get rid of the word constant. Notice this says multiplier, which has multiplication. That's exponential. It's our constant multiplier. A rate of change, okay, that's the slope when we're adding or subtracting. Very good question. Thank you for that one. Okay, and then lastly, carry over your initial values. We had to go backwards. 0, 5. Some number here at the very top, if I multiply that by 2, gets me 10. That was 5. That is your initial value. Some of these pieces might be a little too big, but just try to fit them into the correct spot there. All right, so while you guys are working on that, I want to see how you guys feel about linear and exponential. Now, just by looking at this example, give me a thumbs up if you feel like, oh yes, this makes sense. Give me a clap if you're, no, I'm still a little lost. And you have a third option. If you're like, yeah, it's making sense, but maybe I need more practice, give me another reaction, a different emoji. All right, I'm glad to see those thumbs up. Oh, okay, yeah. If we're in the middle, very normal. It's only been one example. Okay. Thank you, guys.
But that's a step in the right direction, guys.
Yeah.
So that's what we're trying to, do.
Yeah, good. That's what we want. Progress and not just staying stuck. All right, so this is what we're gonna do. For The next two, I'm going to start you guys off with looking at this first question on the left here. You have another table. I want you to follow the steps. The first step, look at your Y values. Find a pattern and determine if that's linear or exponential. Once you find that pattern, depending if it's linear, you'll know it's a constant rate of change. If it's exponential, you'll know it's a constant multiplier. And then use that pattern to find the initial value. So I'm going to give you 3 minutes to see if you can find the pattern. And on your ClassKick side, you have those pattern options here. So you have 2 options. Could it be a pattern of subtracting by 4? Could it be a pattern of dividing by 2? Once you find that, carry the correct piece to tell me if it's linear or exponential. Okay, that's the goal. It's just take a good look at these Y values, find the pattern. What do you notice? And then we'll come back after those 3 minutes and work on it together and see if you were successful in figuring out the pieces there. All right, and if you have any questions, let us know in the chat too. We'll help you out. So I'm going to start the timer, 3 minutes. Take a good look at this table. Follow your steps that are up here. Adding a subtraction, linear, multiplication, division pattern, exponential. Let me take a look on the ClassKick side, how you guys are doing. Okay. Let me take a good look at yours then. Yes, Juan, fantastic. Good. If you want to get a head start, there is a reflection down here that we want to make sure you do. It's just rating yourself on the objectives. Are you able to determine if it's linear or exponential? Are you able to find the rate? Are you able to find the initial value? How do you feel about it? So that's your reflection. No typing anything in there, just circling to rate yourself. I love that you guys are honest in your reflections. That's good. That kind of helps you, that helps us progress. All right, I'm going to give you guys a couple more seconds. We have 20 seconds left, but the majority of you are finished. So those of you that are finished, I'm seeing correct answers. So if you guys wouldn't mind sharing your answers in the chat or in unmuting yourself as we're talking about these, it'll make us go a little faster. And that way we can get to your homework and review it. Yay, Jimena, good, let me check. I think I already saw yours. Yeah, perfect, Jimena. Oh, yay, your reflection, good. All right, I'm gonna go ahead and go back to the presentation and see if you guys were able to come up with that pattern. Another helpful trick is, again, to take a look and see what's going on with these Y values. 14, 10, 6, 4. These numbers are getting smaller. Since they're getting smaller, I should probably think I'm either subtracting or dividing. Yes, good job. Thank you, Juan. So what is our pattern here? We are subtracting by 4. So 14 minus 4 is 10. 10 minus 4 is 6. 6 minus 4 is 4. I made a mistake there. Sorry. 6 minus 4 should be 2. I need to fix my
presentation.
My presentation, but you guys have it correct there. See that mistake that I fixed? So that should be a 2. And that is important because if you don't have a consistent pattern, it's not linear and it's not exponential. So this here would definitely throw it off, and that wouldn't make it linear, but I'll fix it. As a matter of fact, let me fix it now because I don't like seeing it there. There we go. There we go. All right. So we are subtracting by 4 each time. So give me a thumbs up if subtraction means we have linear. Give me a clap if it means it's exponential. Thank you. Thank you. See, your pattern already tells you linear or exponential. Subtraction is definitely linear, which means we do not have a constant multiplier. We have a constant rate of change. So what is the constant rate of change? Well, that's your pattern. What did we say our pattern is? Anyone? Yeah, exactly. If we're subtracting by 4 each time, our constant rate of change is -4. You need to make sure you include that negative because think about our slopes, our linear functions before we went on spring break. If our line was going down, we need to show that's a negative slope. This is a line that's going to go down, which has a negative slope, -4. All right, perfect. Our initial value, well, we know that's where x is 0, so we're going to have to come up here to the very top. And we can ask ourselves, okay, there's some number here, perfect. There's some number here that when I subtract by 4, it gives me 14. What number do I take away 4 from to give me 14? That is 18. Thank you, Jimena. So that is your initial value. And that is the 3 pieces of your objective. That's what we were trying to make sure you can accomplish today. That's what we've been doing Monday and Tuesday, but we slowed it down. We know you guys needed it. And it's all to help you out. So we have our pattern of subtract by 4, which tells us it's linear. That means we do not have a constant multiplier. So I don't want to see an answer there for the constant multiplier. It should be in the rate of change. For our initial value, we have that the number 18 minus 4 gives us that 14 down here in the bottom. So the number before 14 had to be 18. There you go. All right, good job. So we have one more example left. And I know it's probably a little easy to figure out the pattern. But I'm going to give you guys, let me see if some of you need to finish that up. So a lot of you are already done with the last question there, the last table. Yeah. Oh, I was going to say someone isn't, but that was me. All right, so we're going to go ahead and do just jump right into the last table and work on that one together. You guys can help me out with getting answers here. So you have another table. You want to find out, is it linear or is it exponential? Start by looking at your Y pattern. So I'm going to circle all of my Y's here. I'm noticing that from 16, I'm going down to 4, I'm going down to 1, and I'm then going down to a fraction. Oh, fraction's scary. You don't have to worry too much about the fractions, okay? As long as we see that we have a consistent pattern up here, then you really don't even have to worry about the fraction there. So we know the numbers are going down, which is why we say it's decreasing. So it is important to know the difference between increasing and decreasing. This is decreasing. And we're going to start off by finding our pattern. So 16, I have to either add or subtract or multiply or divide to get me 4. And that should be the same from 4 to get me to 1. Yeah, okay. And I'm going to talk about that in a bit. Yes, good job, Juan. Perfect. Okay, so some of you might struggle a little more than others, and that's totally fine. That's part of the process. Everybody's process is different. So some of you might actually try adding. That's fine. You can try that. You'll see that if you add, it won't get you to number 4. So we won't add in this case. So I'm going to subtract, and I know that 16 minus 12. Yeah, 16 minus 12 is 4. So that works. But is 4 minus 12 1? No. So I cannot have this subtraction pattern. So some of you are already giving me these answers in the chat. I have to divide by 4. Good. So if it's dividing, I already have answers in the chat, but let's do the reactions. If it's dividing by 4, is that linear? Give me a thumbs up. Give me a clap if it's exponential. What does this pattern tell us? Thumbs up for linear, clap for exponential, dividing by 4 each time. Yes, good, okay, perfect. Claps, clap, yeah, perfect. It's a clap, so that means this is exponential. Now, I want you to keep one thing in mind. If it's exponential, we know we have a constant multiplier. So this word says it's a multiplier. It's multiplication. So although we see a division pattern, that is correct, is exponential. But when we're talking about writing a constant multiplier, we need to change that division to multiplication. And it's not to confuse you guys or anything. It's very simple. All you have to do is change that 4 into a fraction and flip it over. So instead of thinking of multiplication, we're going to change that. Sorry, instead of thinking of division, we're going to change that to multiplication. And all you have to do is put a 1 over that 4. A 1 over that 4. And now that has turned our pattern into a multiplication pattern of multiplying by 1/4 every time. So multiplying by a fraction does give us a decreasing of an exponential pattern that's going down. So that is not a constant rate of change. It's a constant multiplier of 1/4. And now for the initial value, you just have to think about our pattern here. Our initial values were x is 0. And there's some number here that when I divide it by 4, I get 16. Yes, perfect, 64. And that is your initial value. Now, I know some of you might struggle with the whole multiplication, might struggle with division. Some of you prefer multiplying than dividing. So I can show you another way of figuring out the pattern here, which actually this was brought on by a student in our tutoring session, I think, yeah, last quarter. The student said, I can't see the division. Like, I know it's going down, but I struggle just figuring out what am I dividing by. So this student was very clever, and she said, instead of me looking for a division, let me get a different color, blue. Instead of looking for a division, I start from the bottom, and actually somebody did mention that. Let me see. Somebody mentioned that in the chat. I always start with the little number. Yeah, that's another strategy you can use. So let's say we're starting at 1. You can ask yourself, well, let me go backwards. How do I go from 1 to 4? From 4 to 16? Okay, what can I do for that number 1 to grow to the number 4? Well, I can just multiply by 4. I can just multiply by 4 here. And that even helps you find your initial value. 16 times 4 is 64. But you want to remember that you started from the bottom. I was thinking of a Drake song at that point. You're starting from the bottom. and you're going upwards. But when we read our tables, we start from the top and go downwards this way. So if you were thinking of multiplying by 4 going backwards, you want to change that into your fraction. You want to put the 1 over it. So I love that strategy. If it helps you out, if you understand it, use it. Just remember, you have to end up with that fraction multiplication when you are writing the constant multiplier, if those numbers are going down. All right, so I'm going to go back over here, finish these up, and then we'll move on to reviewing your guys' homework. So a division pattern we said is exponential. When we have an exponential function, we do not call it a rate of change. We call that constant multiplier. But dividing has to change into a fraction pattern. Multiplying by a fraction, in this case, dividing by 4, is the fraction 1/4 when we're multiplying. Working backwards, I found that my initial value was 64. So I just carry that piece over here. All right. So I'm going to ask you guys again. Give me a thumbs up if you feel like, oh, okay, this all makes sense now. I feel good about this. Give me a clap if you're, no, I don't feel good about this. Give me a different reaction if you're in between. Yeah, I see how it's easier. I probably need to try a couple more on my own to see if I get it. Or probably a little more practice is what I need. Okay. Thank you guys. Clap if you just don't. Okay. So it's good. We're not seeing a lot of claps, which tells us that we're at least moving in the right direction. Okay, and these patterns are not going away. We're actually going to be seeing them tomorrow in a graph format. So tables do give us graphs anyways. The graphs also show us these patterns, so we're still working with patterns. I know patterns can be confusing for some students. All right, I'm going to give you guys 1 minute because I noticed some of you are not, and you don't really need a minute, but I'll give you guys a minute to reflect on your ability to meet the objectives from today by rating yourself from 1 to 5. 1 is the lowest rating, meaning nope, I don't think I'm meeting the objectives. Your objectives are, can I distinguish, meaning can you tell the difference between linear and exponential tables? The second part of that objective was, I can find the rate of a linear or exponential function. So rate just means constant rate of change or a constant multiplier. Rate is just how something's changing. And the last one is, can you find the initial value of a linear or exponential function? So I'll give you guys about a minute, maybe less if I see that you guys are all done with that. How do you feel about today's objectives? Are you able to meet them? Oh, and let me zoom out. For those of you that might have had internet issues, this is what your notes should look like. Completely done for today. Take a screenshot of that. And then we're going to move on. We're going to move on. I like that you guys are honest in these reflections. Honestly, it's your reflections that give us feedback of whether or not we should slow it down or keep going. And I saw your guys' reflections. Thank you for the honesty in them. I saw your guys' reflections in the Google Forms homework. And you were telling me a lot of feedback. I don't know about the initial value. I don't think I'm comfortable with that. Some of you were saying, I don't know if it's exponential or linear. So thank you guys very much for that feedback. All right. Ooh, I leveled up. Look at that. I love that sticker. All right. So what we're going to be doing next is taking a look at the homework from Tuesday. That homework is actually very similar to Monday's homework in the Google Forms, but the Google Forms lets you know if you did it correct or wrong, but it's broken up into the same pieces. Your Google Forms had a table. It was asking you if it was linear exponential, and then it asked you, well, is that pattern a rate or a multiplier? And then what is the initial value? So same thing, but we're going to go over your homework number 13 because that one seems to be giving you guys trouble and maybe not finding patterns or anything like that, but actually writing the answers correctly in the correct spot. All right, so do me a favor. You guys can go back to your agenda for week 5. You can get to your homework by clicking on Tuesday where it says 13 here, homework assignment, linear versus exponential functions table. Some of you can also get there from Google Classroom. That's fine too. But you want to get in the habit of checking that agenda to know what it is that you're missing each day. There's also homework assignment 13. So when I click on that, it takes me to this Classkick link that I want to click on. And I will type in my name exactly the same way that I do every day. You want to make sure you're logging in. Give you guys a couple of seconds to meet me there. All right, give me a thumbs up if you were able to get your Classkick homework here, homework number 13. Give me a clap if you need more time to open up that assignment. Thank you guys. Let us know in the chat too if you're having any issues opening that up. All right, fantastic. Okay, we're going to take a look at this homework assignment. This homework assignment is 2 pages. So there's this first page and this second page, okay? You'll notice down at the bottom, oh, yay, thank you, Doc. I just saw that. You had some reflections down here, but since you already reflected on the in the today's examples or notes down at the very bottom, we're okay. We're going to remove the reflection for you today. I want you to focus on practicing. And you also have the reflection on homework assignment 12 if you haven't done that yet, so that's also there. But before I actually get into how you showing you an example of working these problems out, what I want to make sure you pay attention to is that we have these little boxes here with the green broken lines or dashes around that box. They're there so that you can actually type in an answer. So what we've noticed is that some of you are going in here and, I don't know, writing like -5, something like that. And this assignment, if you don't write it in there, it self-grades, meaning it lets you know if it's right or if it's wrong if you type it in. So let's say you still say your answer here is -5 and you type it in. Nothing happened once you click out of it. I'm not getting a point. So if it's correct, you'll see a point here. If it's wrong, you'll see it turn red as in like -1. But if it's not doing anything, then that tells you, oh, that's because I probably shouldn't have a rate of change. So let's say I go down to my constant multiplier. And it never grades me for some reason because but let me anonymize this and show you.
I don't know why.
Yeah, I don't know why. And I know it grades other students because I see the reds or greens on them. All right, let me hide student names. Here we go. I'm going to show you guys an example of what it looks like if it's right or wrong, so you know whether or not you're on the right track. Don't worry if this is your homework assignment, no one can see your name, okay? So see that? There's a red here. It's telling you, you that it's wrong. When you see the green 1 point, it's telling you it's correct. So again, no one can see your name, don't worry. So that's what I'm talking about. All right, so let's take a look at this here. How do we complete this homework? Well, you're supposed to identify if this is linear or exponential. You want to circle 1. Then once you know if it's linear or exponential, tell me what the rate of change is or the multiplier is, and then find the initial value. But if you go back to your notes, you can't do any of that unless you have found a pattern. So you'll want to go back here, look at the y values, your y's, and find a pattern. 6, 12, 24, 48. I know that is growing. How is it growing? Give you guys a couple seconds, see if anybody can either unmute themselves or let me know in the chat, what pattern do we notice there? Yes, thank you, Sammy. Yeah, we're, good job, Jimena. We are multiplying by 2 each time. So you can draw it in here if you see it. Remember, you could use that times 2 there. I would prefer you don't use the X because in the chat, it's totally fine. Don't worry about that. I do need to see at least times there. Times 2 here. If you're using the X, it's not that big of a deal. It's fine. But when we start writing equations, I don't want you to confuse the X's with those equations and the multiplying. So we'll talk about that next week. All right, perfect. So since we know this is multiplying by 2 each time, give me a thumbs up if that's linear. Should I circle linear? Give me a thumbs up. Give me a clap if that's exponential. Good job, you guys. I know it takes a while to go back and forth between Zoom, so even the reactions are a little delayed. Yes, good job. I'm seeing more claps. Good, good, good. See, that's already you meeting that first part of the objective. You know it's exponential because of that multiplication pattern. That's a good sign. All right, so since we know this is exponential, for those of you that already completed this homework, you're going to want to fix this. I don't want to see an answer here. We don't need an answer here. So you can leave that by itself. You can exit out. It's fine. I saw some of you guys actually Xing that out, which is cool. We know it's a constant multiplier. So what is our constant multiplier? What are we multiplying by each time? Thank you. You guys have already told me. It is 2. So if you type in just the 2, it should grade it as correct. I've also put it in there that if you type in times 2, it should also grade it correctly. There's different options there for getting that point. If you put in that space, it should also grade it correctly. If you put in just a 2, it should grade it correctly. For me, for some reason, it's not grading it, but it will for you guys. All right, perfect. So then the last step, you just need to use that pattern here to find that empty space, the beginning. Think of back to the money we started in our savings account. Well, that should be 0. And there's some number here that when I multiply it by 2, it gives me 6. Anybody know what that is? Or if you prefer to go backwards, you can work backwards. I can divide by 2, up to you. Some number here. Thank you. 3. Good. Since we know that y-intercept. Oh, thank you, Juan. That's so nice. Well, I'm very happy you get it. That's why we're here, honestly, to help you guys understand these. All right, and that is your initial value. And there you go. So this is how you would be completing today's homework. I'm sorry, not today's homework, Tuesday's homework. We are moving today's homework to tomorrow because that has to do with something else, I believe. So use today to catch up on homework assignment from Monday, 12, and homework assignment number 13 from Tuesday. If you want to get ahead, of course, homework assignment number 14 is there. You can try to get ahead on that one. But we're basically giving you the rest of the time we have here to complete your exit ticket, to ask us any questions that you might have on this homework, to finish up all of your homeworks there. But that's it. I'm hoping that this really helped you guys get on the right track now for linear and exponential, because we are still continuing with linear and exponential, just seeing them in a different format.